Hello, welcome to Anatomy Lesson 5.04 on the calcium cycle. For this lesson, we're going to be talking about maintaining homeostasis. Some of these terms are a little bit difficult to read. Hopefully you can read them on your paper. But we talked about homeostasis earlier in the year. So homeostasis is defined as the ability of an organism to keep a set of standard conditions. Keep a set of standard conditions. And the way that organisms maintain homeostasis is through feedback loops. And there are positive feedback loops and negative feedback loops. An example of a positive feedback loop would be childbirth, where the woman has a small contraction, and that triggers the next contraction is bigger, and that triggers another bigger contraction. And the contractions continue to get larger until the baby is expelled and the placenta is expelled and the body can return to its standard state. For the calcium cycle, this is moderated through a negative feedback loop. Negative feedback loop. So an example of this would be my home. Right now, I have a thermometer and I want to keep that temperature setting at 72 degrees. As the temperature rises, and right now when I'm recording this, so this is my temp. Right now I have both my propane oven lit and I have my air conditioning on, because during the day what happens is it's going up to about 78 degrees. And so when that happens, my central air will kick on. This is my central air. And bring it back. But then at night, the temperature starts to drop. So my temperature goes down. And when that happens, my stove kicks on and brings it up. So this is my stove. And hopefully then the temperature stays at 72, where I want it to be. Well, your homeostasis of your blood calcium level. So this says in your blood, you want your calcium to be 10 milligrams for every 100 mils of blood. So if you took out 100 mils of blood, your body wants there to be 10 milligrams of calcium. If this starts to go low, your muscles will stop working. It goes too low. Your muscles won't work properly, and you can die from that. This is called hypocalcemia. If it starts to go high and it stays high, which is called hypercalcemia, you have your nerves, everything begins to function improperly, and you can also die from extended, prolonged hypercalcemia. So your body has to have a way, just like my stove and my air conditioner do at home, to keep this at 10 milligrams per 100 mils. So we're going to start with if it increases. So this half of the circle is showing what happens if my blood calcium goes too high, and this half is showing what happens if I go too low. So if I have rising blood calcium level, my thyroid gland senses it. The thyroid gland senses it. So if I start to go up to 12, 13, 14, and the thyroid gland is part of the endocrine system. So this is an endocrine gland. You know what? I'm going to do the top loop in red and I'm going to do the bottom loop in blue. Let's do it opposite. Because I've got blue up here, I've got red down here. All right, so we're going to do top loop in blue. So this is part of the endocrine system. And it releases a hormone. And the name of that hormone is calcitonin, calcitonin. Do you need to know that for the test? Yeah, you do. Calcitonin does two things. So from here, we go through two branches that's going to bring our blood calcium level down. The first thing is reduced calcium uptake in the kidneys. Well, if think about your blood, okay, so if you're going through a cafeteria line and they say you can have as much as you want to eat, and you put food on your tray, after about 4 or 5 things, your tray is full. You can't fit any more on the tray, and you have to just walk past the rest of the food and kind of let it go right on by. And that's what the kidneys do. The kidneys stop absorbing calcium, and if they let it go right on by, where does it go to? Well, what do your kidneys make, guys? Yeah, they allow it to be released into the urine. Allow it to be released into the urine. So, you basically pee it out. The other thing is, it says here, it stimulates calcium deposition in the bones. So we don't want it in our blood. Well, where is our calcium dump in our body? In our bones. And you might think, oh, it gets the osteoblasts, kind of, it gooses them and gets them going. Actually, what it does is it puts the osteoclasts to sleep, in a sense. It has the osteoclasts, it slows down the osteoclasts. Remember, we said the osteoclasts are bone dissolvers. So usually they run around and they dissolve bone, and it kind of just tells them, hey, go take a coffee break, quit dissolving bone. And because of that, then the osteoblasts, as they're laying down new bone and pulling the calcium out, they actually begin to drop that blood calcium level, and we return. So let's just recap that. Our calcium, we have a 2 milkshakes, a hot fudge sundae, and a bowl of cereal. So our blood calcium levels go really high. Well, your thyroid says, can't have that. It's not good for it's not conducive to your good health, releases calcitonin. Calcitonin is going to tell the kidneys to let that calcium go right on by, pee it out. It's going to tell the osteoclasts, take a coffee break, and in the meantime, the osteoblasts will keep depositing bone. Or bone, yeah, say that right. So that's one half of the pie. So what do we do if the calcium levels start to drop? And again, this was the example we gave was in pregnant women. Sometimes if you don't get enough calcium, your fetus will start to suck up all the calcium out of your blood. So in this case, it's not the thyroid that goes to work. Remember those little glands on the 4 corners of the thyroid that are the parathyroid? Let me rewrite that. The parathyroid gland. Hopefully, you know what? I wonder if I should rewrite. I may not be able to read calcitonin. Hopefully you can read thyroid. So the parathyroid glands release a hormone, and we're just going to call it PTH. It stands for parathormone or parathyroid hormone. And here we have not just 2 pathways, but 3. So this is actually a 3rd pathway. So this one doesn't go directly from the PTH, doesn't affect the intestines. So this one goes to the kidneys, and then the kidneys do 2 things. So the first thing is PTH stimulates calcium release from bones. Well, this speeds the osteoclasts up. So PTH speeds the osteoclasts up. And they start dissolving bone like crazy, releasing it into the blood. So they're dissolving bone, which gets released into the blood. So this was number 1. Number 2, PTH causes the kidneys to hang on to every bit of calcium they can. It's kind of like it's saying, okay, kidneys, it doesn't matter if your tray's full, stack stuff on top of the tray. If you need to, stick it in your pockets. Pull out your shirt, and you can put some put some dinner rolls in your shirt. But the kidneys absorb as much calcium as they can. And you stop excreting it. Which means you stop peeing it out. The other thing, and this starts in the kidneys. So let's do number 3 up here. So we're starting in the kidneys. And let's do a little bit of background information. So the kidneys have in them a compound called cholecalciferol. Well, what is this and where did it come from? We produce cholecalciferol in our skin. Back when we did in the integument, we said that metabolism is one of the functions of your integument. But you might be saying, wait a minute, we said vitamin D. Well, cholecalciferol is the same thing as inactive vitamin D. Well, why do they call it cholecalciferol? This is actually the name. But do you want to go buy a jug of milk that says this milk has extra cholecalciferol added? All of the names of the vitamins and the minerals that we have actually have a scientific name. People get a little squirrely when they start to buy things, and it looks like they've got these wicked chemicals added. It's kind of like saying, oh my gosh, did you know they're putting dihydrogen monoxide in the water? Dihydrogen monoxide is a scientific name for water. So this stuff scares people. So they kind of gave it a nice, vitamin sounds like something that you would want to take. So this stuff's already in the kidneys. So let's do letter A. So what the PTH does, the PTH causes the kidneys to turn this cholecalciferol into something called calcitriol. Calcitriol is active vitamin D. Active vitamin D. By the way, this came from, let me switch colors. This was from the skin. It uses UV light and another compound in the skin to make this. Okay, so what? Well, what happens is the kidneys send this active vitamin D, this calcitriol, to the intestines, and the intestines start to absorb the calcium at a much faster rate. So the last thing that happens is the kidneys release the active vitamin D, the calcitriol, into the blood, which causes the intestines to absorb. Got a paper clip here. Where'd that come from? To absorb more calcium. So all of that, we're absorbing more, we're dissolving it out of our bones, and we're not releasing it in our urine, causes our blood calcium levels to rise. So we get back to homeostasis, and this kicks off and on all day long, just like my stove and my central air. Negative feedback loop. So let's recap. If we have hypercalcemia, the thyroid activates and releases the hormone calcitonin. This causes calcium to stop being released into the urine, or allows calcium to be released into the urine, slows down the osteoclasts, but the osteoblasts will keep depositing bone. And so we're releasing it outside the body, we're putting it into the bones, and we bring our levels back to center. If we're low, that's a little more complicated. It starts with the parathyroid releasing PTH, and we get three things. It speeds up the osteoclasts, so we dissolve calcium out of our bone. In the kidneys, we stop excreting it, we absorb more. Also, the kidneys convert cholecalciferol to calcitriol, which is basically turning inactive vitamin D into active vitamin D. And it causes the intestines to absorb more calcium. You have to have, one of the things they talk about living in Ohio, vitamin D deficiency is off the charts. Why? This is from the skin, and you need, and the sun. So if you take the sun and the skin, you have to have UV exposure to produce the precursor. Do we get a lot of sun in the wintertime here? No, we don't. And they've linked that to a lot of diseases, including multiple sclerosis, increased risk for breast cancer. So guys, one of the supplements you should definitely take is vitamin D. It's really needed if you live in Ohio. The other thing I want to say is this is our first big meaty example of physiology. This is not anatomy. We're not memorizing parts. Physiology often expresses itself as a cascade. One thing leads to the next, leads to the next. This leads to that, and we go off on a branch here. So there is still a lot of memorization, but you have to understand how one thing leads to another. So that is, we did this all in one video. I was thinking about doing it in two, but I think that covers everything we need to do with the calcium cycle. Thanks for watching and have a good day.